Hello there and welcome back. In this video, my plan is to show you how you can create a wake on LAN script in Python. So wake on LAN is basically a LAN feature which allows you to wake up devices or start devices that are able to receive and process this packet. And recently I have been tasked to basically rewrite, I think, a PHP solution or a Bash solution at my current workplace. It used a different approach because we used @wake. So that is a CentOS solution. And that's a command line utility that you can install, and it allows you to wake up devices. And basically, I want to show you how you can do it in Python, in pure Python. And we are going to use a YAML-based configuration file to define the devices that we want to wake up. So let's get to it. This is going to be, let's say, longer video. Let's create a directory. Where am I? In the coding folder, WOL. And open up our favorite text editor, which is NeoVim. So here we are in the wake on LAN folder. I press the M, add the child node, and let's call this WOL.py. And I'm going to give the full real estate to the screen, and we are going to jump right into it. So technically, what we want to make sure is that we have a config folder, and WOL.yaml is going to be the configuration file. But first create the config folder and then create the WOL.yaml. And this WOL.yaml is going to be a YAML file. So we will have basically a list of machines and a list of credentials and some settings. So the basic idea is that we are going to send the wake on LAN packets and then have a sleep or a timeout. This is the time that we give to the devices to wake up. And after that, we are going to use Paramiko to SSH into those devices and check their uptime. And this is what we are going to implement. So let's get right into it. So basically, we are going to have a machines section, and let's call this machine 1, and it is supposed to have an IP address, which is going to be 192.168.0.1, and it is going to have a MAC address. Let's create a MAC address generator, and technically, what should we do? So, or just, you know what? ipconf. Oh, you know what? I'm going to use parallels and basically start up this CentOS machine that I have, and we are going to SSH into that device. So CentOS 9, let's wait for it to reply. Okay. Great. So let's try to SSH into it. And let's see the MAC address. This would be an example. And what we also want to do is to make sure that we have a machine 2. IP is going to 192.168.0.1 or 2. And the MAC is going to be different with one number. And as I mentioned, that we want to make sure that we have a credentials section. So credentials, and we have basically a username, and this is going to be admin, and the password, which is going to be admin, and we have a settings, and this is going to be a retries 5, and the sleep is going to be 500. So this is our settings file, and you can imagine that you can easily extend it with a new machine. You just have to define this different or new section. So how does the wakeonlen.py look like? Basically, what we have to do is to import the OS module, the sys module, and the logging module. And we have to import from the yaml module the safe load, and from logging.handlers we import the rotating file handler, and from the time module we import the sleep function, and from struct module we import the pack function, and from socket we import socket, sock, dgram, sol, socket, af, inet, so broadcast, and the sol. Oh, that's already imported. Okay, so first we have to get our current working directory, and we use the os.path.sep.join, and basically we say that whatever the file name is, we want to split by the os.path.separator, and we take a subset of this until the last section. So if I go ahead and print the CWD, so let's save it and exit it and enter the WOL and run this. Oh, we are not just going to need the YAML, but we are going to need the pyaml and the paramico modules. So pyaml is going to be needed to process the configuration file, and the paramico is going to be needed to make sure that we can SSH into the remote host. So we have os pass join, and we split it, and so we have to use the ABS path. So os.path.abspath, and we want to use the absolute path of our file, and we split it with the os.path.separator, and we go ahead and use the subsection. And now if we run it, you can see that here we are in the actual folder. This is the current working directory. And we have the config variable, which is going to come from the os.path.sep, joined by the current working directory, and the config string. So if we print out the config and run it, we have the os.path.sep.join. So we have the config folder, and we need a log folder. So os.path.sep.join, and we say we want to join the current working directory with the logs folder. And we are going to have the config file, which is os.path.sep.join, the current working directory, or rather the config, with the WOL.yaml. And let's print it out. Config file. Okay. So the next thing that we want to do is to specify a set of folders which we expect to be present. And these folders are going to be the logs folder and the config folder. And we want to iterate over the folders and say that if not is os.path.is.directory folder, and we should use the os.path.sep.join and current working directory and folder. Then basically what we want to do is to use the os.mkdir, and we say that os.path.sep.join cwd and the folder. Now if you run it, you will see no output, but if we go ahead and remove the config and the logs, then check the directory, and if you run this solution again, the folders are going to be in place. So now the next thing that we want to do is to define our logging. Let's remove this print statement, and we say that the logging.basic config is going to have technically a format and the log level. Okay. And then we will have the logger. set to logging.get logger. And we say that this is called WOL. And we are going to define a handler, which is going to come from the rotating file handler. And we are going to have the WOL.logs, which is going to be the log file. And we will have the format, which is the ASCII time. And then we can say that logger.info, and we have this hashtag with the 50 as a separator. Okay, so this is going to be the os.path.separator.join. All right, now we have the logging in place. So the first thing upon running, which we have to check, is to whether we have the configuration file. So if not, os.path, that is file, config file, then we can say that logger.critical, there is no configuration file. And we can say that raise system exit, or rather, let's use the sys.exit with the -1. And let's put there an info with the separator. So let's give it a 50 octotrope. Non-printable character. Okay. So there is no configuration file. Let's create it. So we have the wol.config, and I think I should restart the NeoVM. So wol config, create a child node, wol.yaml. And technically here we have the configuration file template, and we are just going to simply repurpose it. So let's insert it, machine IP and stuff like that. So now if we go back and run it, you can see that the execution is not going to stop on that part because we have the configuration file. Okay, so the other thing that we want to do is to say that we want to read the configuration file. And here comes the PyYAML part. So logger.info reading configuration file. How do we read a YAML file? We basically say that we want to use the try with open config file, and we don't specify a mode. We just say that this is a Y file, and the config is going to be equal to safe load of the config file. And we say that logger.info success accept exception as E logger critical, and could not read configuration file. And we print the message. Let's not forget the F. So it's an F string and it's interpolated. And let's exit with 1 or -1 with the sys.exit. Okay, logger.info. Hashtag times 50. Let's try to run it. As you can see, we have successfully read the configuration file. Now, from the configuration file, we have to pull out the machines, the settings, and the credentials. So let's try to do that. What we can do is to say that we want to try. So logging logger.info, and we say that pulling sections, and we say that the machines is equal to config machines, and the settings is equal to config settings, and the credentials is equal to config credentials, except exception as logger critical, and could not pull sections because All right, let's make it an F string. And we use the logger.info with 50 and the sys.exit -1. Otherwise, we want to print the machines and the credentials and the settings. So basically, this YAML file is going to behave as a dictionary in Python. Let's run it. What? So we have it here, and we have the credentials and the settings. What's wrong? Let's print the config. Hold on. This is Y file that we want to load. Okay. So now we have the appropriate sections. And as you can see, this looks like a dictionary. Okay, now we have the sections. And technically, we should implement a check. So we say that, or no, I mean, if we take it as a face value, we could say that if we get past this try except block, we should be able to proceed. Okay, then let's let's try to do it this way. So logger.info configuration items are in place. And we say that for machine in machines logger.info we just want to create a printout of these machines. So machine IP with the machine dot Mac, and we say that machines machine let's save it, and let's not forget to make this an F string. IPv4 and Mac. Great. So the next thing that we can do is to iterate over these machines to the amount of retries that we defined in our configuration file. So here we have the number of retries. So in my experience, the number of retries is relevant because in some cases, this WOL packet is not recognized by the network card. I don't know why, but if you say that you want to try it 5 times, that's a safe guess that in one of those 5 attempts, the network card will notice that there is a WOL packet sent to its way. So, for retry in range settings and retries, and then logger.info retry. Let's try to make it an F string, and we say that logger.info waking up devices. Great. Now you can see that we are attempting it 5 times. So let's implement the WOL strategy. I think I'm going to break it up to a second video where we are going to implement the verification. So what should we do here? Yeah. So basically, we have to say that for machine in machines, and we are just going to print out an information stating that we are working on machine and machine. Let's save it and give it a try. Okay. And technically, here comes the fun part. So we have to create a magic packet, and this is going to be using the machine, and we are going to use the MAC address of this machine, and we replace the colon with nothing. So if we go here to the macOS machine and grab this MAC address, which should be it. Oh, this is good enough. Let's copy it and go back here, and we save it and quit it, and we paste the MAC address here and a different MAC address here, and we write it like this: 192.168.0.1. So what happens here is that we replaced the colon with nothing, and then we are going to create data that we want to send, and this comes from the join function, and we are going to use this many capital F characters, and we say that we want to use the magic packet times 20. And if we print the data and execute this, what should we say? Ah, I forgot the brackets. You can see this is how the magic packet looks like. This is based on the standard definition of the RFC. And technically, we are also going to craft send data. So send data. And this is going to be a byte string. And we use a range function. And we go from 0 until the length of the data. And we are going to go by 2 characters. And we say that the send data is going to be equal to the binary data or byte data for join. And we say that we want to join the send data with the pack function, and we say that we want to use the big character and the int for the data brackets j colon j plus 2 by 16. Let's print the send data and save it. So this is what we want to send to the devices. And once we have it, we should create a sock variable and use the socket af inet sock dgram, And we say that the sock.set sock option sol socket so broadcast and 1, and we say the sock send to with the send data to the machine IP. So basically we crafted this packet and we are trying to send it to the IP address of the machine, and we use this 7. And we use the logger.info send data. So this was what I wanted to show you in the first part. What we can also do here is to say that now we have sent the packets and we want to use an f-string to mention that we are sleeping for settings and sleep seconds. Okay, so we are sleeping for 500 seconds and we just want to call the sleep function for the settings sleep. And now we are waiting 500 seconds. And in the next video, we are going to see how we can verify the uptime in case of the Linux machines. That was all. See you in the next one.